For those who don't know me, who am I? As Jordi was telling me, my real name is Carlos Eduardo Arango. I prefer going just by Eduardo to avoid issues in the airport for having a really long name. I've been a developer for Singularity almost 3.5 years now, since it was an open source project in the 2.0 version, and I now work for Sylabs full-time, 1 year and 8 months, something like that ago. This is my Twitter handle, my email. I guess this is going to be the hashtag for the event, right? I guess it that. And feel free to follow me on Twitter. I'm open to questions about containers, about HPC all the time. Doesn't need to be about containers at all, just about science and HPC. I'm always open to questions. I want to start with a brief history of what Singularity is and what containers are, because yesterday I was having a really awesome conversation with some speakers back at the hotel. And turns out that in every tutorial that you jump out, people still think that containers are some kind of black magic, black box, and that should just work. And there are some assumptions on containers that we should not be taking back to our development desktop, and that we should be thinking on why containers are here and that they are only just a tool. So Singularity as tool Singularity, it was born back in 2015 in late October because people were requesting containers like Docker into HPC multi-tenant facilities. It was a big no for the security side of things and also for the integration side of things. So Greg Carcer, the same developer as CentOS, for those who know who Greg is, started Singularity back then. Then it quickly, thanks to academia, thanks to universities, it became into the 2.0 version. And from there, a lot of HPC developers really bootstrapped the project, and it was a really fast-growing open source project. To today, that is in the 3.x series versions and is growing. We have more than 1,000 developers join in our GitHub repo right now. So it's a big open source project. But what are containers really? So I really like this slide. I've been using this slide for almost 2 years now, and really to people understand why are we here talking about the new wave of HPC. And is that what we really acknowledge as containers that really started back in 2000 with the FreeBSD jails? So for those old school people, the concept of container was really started by the, this has a point, okay, by the FreeBSD jails people, and it wasn't up until the LXC, the canonical developers, in 2008, started with playing with namespaces and created a rough CLI to start playing with namespaces and C groups, and they called that Linux containers. So that was back in 2008, almost 10 years from now. So containers are a 10 years technology in an old school environment like HPC. So this is a new technology for all of us. But it wasn't until 2013 where Docker started to look at the LXC libraries. And if you guys are playing with LXC, you can know that LXC is not that user-friendly. So the guys at Docker, they created a user-friendly CLI to interact with the LXC libraries. So the first, I would say, 1.5 years versions of Docker, they were really about just a fancy CLI around the LXC libraries, from which they dropped the LXC libraries and they started their own projects, which is what we now know as the Open Container Initiative, RunC, Containerd, all of that, was when they decided to drop the LXC libraries and start their own. But you can see that it's a really new industry, 2013. It wasn't until 2014, 16, on which the Kubernetes project, the CoreOS people said, okay, Docker is doing a good job with doing a fancy CLI around LXC. Now we can start playing around with this and see what we can do with containers. And last month I was in the Red Hat Summit, and for me it's really interesting that Canonical developers were the guys that started all the container wave, and is now Red Hat who is making the most of containers. So you can see how quickly the container ecosystem is moving. So I hope you guys enjoyed this slide and understand that this is a new technology that is changing really fast, is not mature enough. And for the HPC, the ideal scenario, why containers are being embraced in HPC. What every system admin would love to see is every users in their facility being the same user, just requesting the same 3 apps with the same version, with the same everything, so they don't have to play with modules, they don't have to play with containers, with RPMs. It's just the same 3 apps, the same 3 versions, done. System admin, real life, heterogeneous users with heterogeneous applications. Sometimes they want the same application with different versions. A lot of times it's Python, so we have developers that want Python 2 point something, developers that want Python 3 point something, and all that in the same multi-tenant infrastructure. And this is the system admin daily basis life. And this is why containers are being embraced into the HPC ecosystem, because it was getting kind of hard and difficult to handle all of this just with modules. So the HPC solution to this problem was modules. But then we started to look at containers, and it was really a bottom-up solution. So it was not the system admin telling the users, hey, you guys should use containers so I don't have to play with modules in the cluster. It was really users playing with Docker and LXC in their workstations, in their laptops, and going into the system admin and telling, oh, you know, all my research is now in a container. Can you run this container for my research, for my paper, or for my development of whatever I'm doing on HPC? So it was a bottom-up solution that all the system admins now and the, the HPC admins are dealing with. So we are being pushed to use containers just because the developers are adopting these technologies. So I hope you guys enjoyed the containers one-on-one. If you guys have more questions, feel free to. This is a tutorial morning, so it's not just me talking here. So I'm open to you guys raising a hand and I'm answering questions. There's no waiting until the end for questions, okay? Now, back to Singularity, my wheels. It was designed specifically for HPC, but now we're moving more into the OCI ecosystem. So Singularity was designed in a way that LXC and Docker don't play, which is integration with the underlying hardware, right? So by default, LXC and Docker, they use C groups and they use some namespaces that were taking away the HPC developers from using specialized hardware. So InfiniBand, GPUs, or those kind of things that we know for sure in the HPC ecosystem, they were not something regular and normal for the cloud native people, so they were not interested in integrating with those kind of tools. So this is why Singularity, and now we also have Charlie Cloud and Shifter, they are really focused on integrating with the underlying hardware. So by default, Singularity supports GPU, InfiniBand, OmniPad, MPI processes. I tried to play with MPI processes within Docker and within LXC. It took me like 2 or 3 days just to set up the network and all that, to go away from all the namespaces and C groups that they use by default, and it gets really hard to use an MPI process inside those technologies. What we are calling now containers is the way that developers can bring their own environment, so BYOE. So they can just build their environment in the workstation and bring that into the cluster, bring that into the HPC ecosystem. So this is what developers are getting from containers. And this afternoon, Kenneth is going to show us how they are built. You can build then a container with their environment via easy build and fast track the way people are building, not containers, because for me the container world is already moving, is how can people build their working environment and start deploying into the HPC ecosystem. So a little bit of explanation when people have the question in their minds, what's different between Singularity and the OCI. Singularity doesn't play with layers. So this is the main characteristic of Singularity before getting into the runtime characteristics. So if you are aware of Docker or OCI, runc, Podman, whatever, the container image is stored as layers. So you can think kind of as a Git structure. So every time you do a change, a modification in your container, it is not being stored in the container image itself. It is creating a new layer on top of the base layer and storing that this layer is a modification of the underlying layer. And on the HPC, when you start talking about really heavy I/O processes, so when you start storing and creating, modifying a container over and over and over again, one layer is okay, but 2 layers, 3 layers, after 1 week, 2 weeks of working in the same container, you then are having a problem handling all the layers that you have in your container. So this is why Singularity was designed as a single container image. And we all know this as a POSIX file, right? So Singularity for the old school people is really a file system in a tar file. Now, in the 3.x series of Singularity, we developed our own version, I can say, of star files. So we have a binary file that we call Singularity file format, which is a Singularity developed binary format on which we have all the file system and the metadata for running that file system inside a single binary file. So moving away from layers, the other main characteristic of Singularity versus OCI is the runtime. So we don't leverage by default runc as everyone else is doing, so you can play with the OCI ecosystem. Because the way they are using namespaces is not a good fit for HPC, and that, again, from the last slide, that takes you away from using HPC regular infrastructure. So the Singularity runtime is different. We use a setUID workflow. Now with the 3.x series, you can choose if you are going with the setUID or non-setUID. You can just leverage the namespaces. And it's a really secure runtime versus the OCI, which by default is going to run as root inside the container. For Singularity, you are the same POSIX users. You are outside the container. You are the same POSIX users inside the container. And what this is giving you is that after you install Singularity in your infrastructure, you only need to worry about users, not about Singularity. So every time I go into conversations with system admin, I tell them, Singularity wants to give back the power to the system admin, giving all the good things to the developers. So system admin now can just worry about what permissions I'm giving to my users in a POSIX way of giving user permissions, and those same permissions are the ones that Singularity is going to read and give to the processes that I'm going to be spin up into the namespaces. So I guess we have some bit of academia people here. Another good feature of Singularity being a single binary file is that it is helping researchers and academia into the reproducibility and mobility of your container, of your image. So if you are submitting a paper, if you are going to a conference and you are getting a peer review, you can just ship your container into the peer reviewers with your binary file and your PGP keys, because Singularity right now allows you to send your container with your personal PGP keys. And the peer reviewer is going to verify that it's your container, run it, and test that whatever you are saying that you are fixing or curing cancer in your paper, it's true. So this is one of the features of Singularity, allowing researchers, academia, to get more reproducibility and mobility of compute with a single binary file. Questions so far? Okay. So let's talk about a little bit about schedulers. So really all this slide can be compressed into, once you can run a process as a POSIX user, there's no interest in talking back of a container runtime, because Singularity then turns out into yet another binary in your host that is going to be running processes as your POSIX user. And then by doing that, you can then integrate with whatever batch scheduler you have, resource manager, and just start running processes as you in your HPC facility, which by default with a OCI or a container daemon, you cannot, because processors are going to be spun up by a root user or a forked user, which is something that the OCI rootless people is doing, is that they are forking the process. And the process, yes, is being run as a non-root, but it's being forked. And when it's forked from the main process, then Slurm, PVS, HTCondor is not able to track the process, and it loses a way of logging and monitoring that process in your workflow. So Singularity is not forking the process once you call Singularity in order to spin up a rootless process. So we can play really nice with any scheduler out there, from Univa to Slurm to PVS to whatever, to the HPC now scheduler. So this is something that we are going to play with in the tutorial today, is that the Singularity 3.x series allows you to sign your container with some existing PGP keys in your host. And then you can sign your container and verify it in a different host. So as I was telling, the academia research workflow, the way we're seeing is that people can sign their containers, they ship the PGP keys to the peer reviewer, the container, and that person can then verify the container. If that person doesn't have the public PGP keys of whoever user signed the container before, Singularity is going to say that it cannot verify and cannot trust the container, and it's going to ask you, do you still want to run this container? Yes, no. So this is a 3.x feature on which you can use PGP old school protocols to verify a container. And then here we are adding a trust workflow for containers. And I really like an analogy that someone was doing to me last month is, nowadays, no one is going to open a web page that doesn't have the HTTPS, right? So by doing a PGP signing and verifying of a container, here we are adding the S, the HTTPS, to containers. So if you cannot trust the container, you are not going to run the container. And in the Singularity configuration file, you can even tell Singularity, if this is not a trusted container, do not run it, just because I don't want to run non-trusted containers. So here we are adding trust to container runtimes. IoT and Edge. So right now, I'm working with some IoT and Edge developers with Singularity. So Singularity being a really lightweight container runtime, now with the AI, ML, IoT, Edge buzzwords ecosystem that is arriving, we are seeing a lot of people trying to leverage the DevOps workflow with containers. So you train your AI, ML model in a big HPC infrastructure with some NVIDIA, GPU, Titan, or whatever. You create the container, you sign it, and then you ship that lightweight container into your Raspberry Pi, into your NVIDIA Nano, or whatever edge device you have, and then you run it in a trusted way. And right now we're seeing a lot of use cases with IoT and Edge by being a lightweight container runtime that is running as POSIX, because it's really hard to get running container daemon into these small IoT devices. Because something that we are seeing from some IoT developers is that the container daemon was Docker or all these OCI runtimes is really energy heavy. So now when we go into the IoT realm, energy and power consumption becomes a factor of decision. And Singularity is a binary. If you're not running Singularity, Singularity is not consuming energy from your IoT device. Rather, if you're using Docker, Docker is consuming power from your IoT device, rather you're using it or not. And we have developers trying to use IoT edge devices. They call me and they say, hey, I want my Raspberry Pi to be running with a power battery for a week. And I don't have a way to go and charge the battery a full week, so I need to be really low on power consumption. So being a lightweight container runtime is allowing users to have an IoT edge workflow. And then we're playing with Azure, Amazon, and Google Cloud on helping these developers to move around their containers from the cloud into the IoT. This is a thank you slide, and I hope this repeats this year, is that for 2 or 3 years in a row, we have been winning the HPC Wired Users Award, and thank you for all you here that are Singularity users and have been giving us the thanks with these awards. So this is a quick abstract that had questions before we jump into the hands-on tutorial. This was really a super quick one-on-one of Singularity containers. No questions? Okay. So this is a really high-level architecture of the Singularity binary file that I was telling you. If you are interested in how this plays, feel free to reach me in the coffee break. Yeah. So again, the question, who here doesn't have a working Linux terminal? Oh. One instance. Okay, so for the next session, we are all going to need a working Linux terminal on which you have sudo access. So the ones that doesn't, please feel free to raise their hand. Kenneth is going to pass the user and the password into some AWS instances. You need SSH access, even if you're running Windows. So that's like the only prerequisite. So we are going to take 5 minutes to help people getting into these AWS instances so we can start the tutorial, okay?